Welcome to another video. We have another question on waves. A sinusoidal wave travels along a string. The time for a particular point to move from maximum displacement to zero is 0.170 seconds. What are the period, frequency? The wavelength is 1.4 meters. What is the speed? Okay. All right. So to solve this question, now let's look at these statements. We have here that the time for a particular point to move from maximum displacement to zero is 0.170 seconds. So which means in this case, I'm going to draw a wave profile diagram, to explain why we have a particular point to move from maximum displacement to zero, okay, and the time is given to be 0.170 seconds. Now, here is a snapshot of a wave profile, okay. This is when we have two cycle or two segments. So let's say we have point at P and point at R, okay, to be the maximum point, okay. Then at Q, and this is the point at Q, and this is point at S, PQRS. So according to the question, so if we have, let's say we have distance or displacement, okay, with respect to time in this case, okay. So this is the time here will be one half of a cycle, and this is exactly one cycle. Then this will be this will be 3/2 times t, which is the time period. Then this will be 2t. So t here is the time, and the unit of time is the seconds. All right. So according to the question, the time for a particular point, okay, to move from maximum displacement, okay, to zero. Maximum displacement is when we talk about amplitude, which is the maximum displacement undergo by the particles of the disturbance, or the maximum displacement from the center of disturbance, okay, or from the equilibrium, okay, from the equilibrium point or position. All right. So which means from maximum displacement to zero, okay, maximum displacement to zero, this is the origin. The time here will be t/4, okay. So it means that the time for a particular point to move from maximum displacement to zero is 0.170 seconds. So which means from the maximum displacement at P, okay, to zero, okay, the time, okay, for that point, for this point will be t/4. So which means we want to know what is the period. So to calculate the period, so the first task is to calculate period, okay, period, which is the time taken, okay, to go through one complete cycle, okay. That's the time taken by the wave to go through one complete cycle, or the time taken that's the time taken by the wave, okay, to make one revolution or to make one cycle. All right. So in this case, so to calculate the time period, so we have that a particular point, that we have for a particular point to move from maximum displacement to zero. Okay, so we have for a particular point, to move from maximum displacement to zero, okay, time period will be t/4 equals to, so the time taken for that point, okay, to move from maximum displacement to zero, okay, will be t. So we have t to be equals to 0.170 0.470 seconds. So we want to know the time period. So time period will be 4 multiplied by 0.170, okay? And this will be 0.68 seconds. So this is the time period. It's as simple as that. Okay, then B. Okay, we want to know what is the frequency. You know, frequency is a reciprocal of time period, or we can also define frequency as a number of cycle made in 1 second. Okay, so to calculate the frequency, Mr. F, okay, to calculate the frequency, so we have frequency is equals to 1 over t, okay, and that will be 1 divided by 0.68, 0.68 seconds. Per second is the unit of frequency. So 1 per second equals to 1 hertz. So the unit of frequency here will be hertz. So we have F to be equals to 1 point, this will be 1 point, this is going to be 1.41 hertz. This is 1.41 hertz. Let me verify. It should be 1.41 hertz. 0.68. Okay, 1.47 hertz. 1.47 hertz. 1.47 hertz. Okay, so then C. Now we are giving the wavelength to be 1.4 meters. Okay, we have wavelength to be 1.4 meters. What is the speed? Okay, so we want to calculate speed of the wave. What is the speed of the wave? Okay, now formula for speed in this case will be V equals to F lambda. V equals to F lambda. F is 1.47. So we have V equals to 1.47 hertz because frequency is 1.47 hertz. Okay, we already have that here, 1.47 hertz. Then multiply by the wavelength, which is 1.4 meters. Okay, so 1 hertz is per second. So that means the unit of velocity will be meter per second. So in this case, this will be V equals to 1.47 multiplied by 1.4. Okay, the unit is meters per second. To be sure, this should be 1.21. Okay, this is 2.1. Yeah, 2.1. Yeah, 1.47 multiplied by 1.4. So this is 2.058. 2.058 meters per second. And this will be approximately 2.1 meters per second. So the velocity of wave or the speed of wave when the wavelength is 1.4 meters is 2.1 meter per second. The noblest pleasure is the joy of understanding. Bye-bye.